Hello, my name is Alok Longodein. I'm a student from Ineso, Hungary, studying biomedical laboratory sciences year 3, and my reg number is 2321029. So today we are given a task to present on the module applied to immunology, given some questions to answer in presentation. So my questions start from question number 16 to question number 20, in which question number 16 says, what makes vaccines effective? So what causes the effectiveness of a vaccine? That's what the question is. So vaccines effectiveness depends on several factors, which includes number one is antigen selection. How you select your antigen? The vaccine must contain the right antigen, a piece of pathogen such as protein or activated or inactivated pathogen that the immune system can recognize and respond to. The other thing is immune response. So the vaccination should stimulate a strong and appropriate immune response, including both humoral antibody mediated and cellular, which is T cell immunity. The third point is memory formation. A good vaccine induces long-lasting immune by helping the immune system to remember the pathogen so that it can respond rapidly if exposed in the future. Safety, which is number 4, the vaccine must be safe with minimal side effects. It should have minimal side effects ensuring that it does not cause harm to the recipient while providing protection. Stability. The vaccine must remain stable in the storage during distribution and maintain its effectiveness. It should be stable for the vaccine to be effective. This brings us to question number 17, which I put as question number 2. How do mRNA vaccines work? So mRNA vaccines work by instructing cells to produce a protein that is part of pathogen, stimulating an immune response. So number 1, the mRNA delivery. The vaccine contains messenger RNA that encodes the proteins from the target pathogen. We have an example in the bracket, which is spike protein from CoV virus 2. Spike protein from CoV virus 2 is an example of mRNA delivery. Then we have protein production. Once inside the body, the mRNA is taken up by the cells. It's taken up by the cells, which can use it as a blueprint to make the encoded protein. We have immune activation. The immune system recognizes this protein as foreign, triggering the immune response, including the production of antibodies, activation of T cells. Then we go to memory formation. If the person is later exposed to actual pathogen, the immune system can recognize and fight more efficiently. And this, so question 18, which is also question 3 here, asks, why are adjuvants used in vaccines? So adjuvants are substances added to vaccines to enhance the body's immune response to vaccines antigen. So they worked by first boosting the immune response. Adjuvants help increase the strength and duration of the immune response by stimulating the immune system to be more responsive to the antigen. Then improving the immune memory. It helps to promote the formation of long-term immune memory, ensuring better protection upon future exposures and pathogen. So thirdly, it reduces the amount of antigen needed. Adjuvants can help the vaccines to be effective with similar amounts of antigen, making the production more effective and potentially reducing the costs. Culturing the pathogen. The pathogen is grown in laboratory environment. The pathogen is grown in laboratory environment in cells or animals that are not typically natural hosts. So those animals or cells should not be typically natural hosts. The live-formulated vaccines are made by weakening the pathogen, bacteria or virus. It cannot cause diseases, but it still triggers the immune system that typically involves culturing the pathogen. The pathogen is grown in laboratory, often in cells or animals that are not typically natural. So culturing attenuation, the pathogen is then modified to weaken. This involves the genetic manipulation, serial passage, growing the pathogen in conditions where it adapts to a less virulent form, or exposure to chemicals or radiation that reduce its ability to cause diseases. Testing. So after attenuation, the pathogen is tested to ensure it can still protect immune response, but it's capable of causing the disease in healthy individuals. Then formulation. The attenuated pathogen is then included in vaccines or added with stabilizers and adjuvants. This brings us to the last question. So this brings us to the last question, which is question 5 on my slides, and it's question 20 on the given questions. So what are the advantages of subunit vaccines? First of all, what are subunit vaccines? These are vaccines that are made from pieces of pathogen, such as proteins. They are made from proteins rather than the whole pathogen. Its advantages include safety. Since they don't contain liver or the whole pathogen, subunit vaccines pose lower risk of causing disease. They have lower risk of causing disease since they don't contain liver or the whole pathogen, making them safer for immunocompromised individuals. Then, targeted immune response. These vaccines focus on specific antigens that elect the strongest immune system, which can make them more effective. Easier to produce. They are easier to produce. Subunit vaccines are generally easier and quicker to manufacture compared to the whole pathogen, especially for complex pathogens, since we know that it's only a piece of pathogen that is taken, not the whole pathogen. Then the less risk of side effects. Since they contain only parts of pathogen, the subunit generally have fewer side effects. It has lower side effects than the live vaccines that can be mild illness in some cases. So this brings me to the end of my presentation. I would like to say thank you. Sorry my camera was not that really clear, but just bear with me like that. Thank you and have a nice day.